Okay, so question B, again, what we need to do first is turn it into standard form. This is quite nice that we get to just practice a bit of algebra along the way as well, because it is such an important step that we're going to have to use our algebra skills. So I'm going to go for the first method, which is turn both into standard form and then put them equal to each other, because that's the method that I just prefer at this stage very much. So for this one, x minus y equals minus 1. Well, it looks similar to the other question we had. We need to subtract x from each side. That's an x, right? Terrible looking x, right? Minus y equals minus x minus 1. And then we need to multiply this whole side by minus 1, or divide the whole thing by minus 1. Amounts to the same thing. So let's multiply everything. In other words, very informally, let's just change all the signs. But we want a positive y, so it's y equals x plus 1. Which must be this graph here, right? Because of the y-intercept being positive 1. And we can see the gradient. Look at this gradient. For every one step across, we're going up by 1. So that's what this 1 here is for. Okay, or the gradient. And the other graph, 2x minus y equals 0. Let's do a similar thing. Well, for this one, I'm going to do something different, just to expose us to different forms of algebra, and go plus y plus y. So 2x equals y. But it would be nice just to put the equation the other way. Y equals 2x. Okay, so there are two equations. Now, quick question as well. What's the y-intercept of this function, this second function, y equals 2x? We can see from the graph and from here, look, we're plusing 0. In other words, our y-intercept is 0, 0. Okay, what do we want to do? We want to see when the two graphs are equal to each other. So we want to see when is y equals x plus 1. We want to see when is that equal to y equals 2x. So in other words, when is x plus 1 equal to 2x? Okay, equation, let's solve it. Let's go for green and say, you know what, I'm going to subtract x from each side. Subtract x, and what are we left with? Well, on this side we're just left with 1, a positive 1, and on the right hand side we're left with, well, I almost wrote 2x. We got x, right? 2x minus x. X equals 1 matches our picture. That's why it's nice just to have the picture to confirm it. Substitute into either equation. I reckon this one looks easier, but hey, add 1 to it or multiply it by 2. 1's quite a special number that you're going to get the same thing. So in other words, y equals 2 times 1 or 1 plus 1. Which one do you prefer? Let's go for 1 plus 1 equals 2. So our point is 1, 2. For this step, we just subbed it into that function. Or we could have subbed it in here. See, 2 times 1 is 2. There we go. There's our point. It's at 1, 2 matches. 1, 2. That's where the graphs are equal to each other. In your other method you might have changed this. Now notice that those that are using the method are often going rearranging it so it's x equals something, x equals something. It's very seldom that we want our equation to say x equals something. We normally want it to say y equals something. What's our output when we're given our input? So I'd rather you practice changing it into standard form. So that's question B.